Magandang araw mga kasipnayan! Welcome to Sir Ocnic's YouTube channel. In this video, we will solve problems involving segments on circles. Let us have our first problem. Two chords intersect in the interior of a circle. Two segments of one chord is 21 and 28 respectively. The lengths of the two segments of another chord is in the ratio of 3:1. Find those lengths. Let us illustrate first our problem. We have two segments, TN and SP. These two segments are chords. They intersect at a point inside the circle at point M. We are going to use the concept of two-chord theorem. Based on our illustration, we may form the formula SM times MP is equal to TM times MP. That is based on the two-chord theorem. Let us try to find the value of SM and the length of MP. By proper substitution, we will have x times 3x is equal to 21 times 28, which is equal to 3x squared is equal to 588. Dividing both sides by 3, we will arrive at x squared is equal to 196. Since we are asked to find the value of x, let us try to get the square root of both sides. And that is equal to x equals 14. That means that the measure of segment SM is equal to 14 units and the measure of segment MP is equal to 42 units. Problem number 2. In a circle, segment AB and segment BC are secant segments with external segments segment BD and segment BE respectively. If AB is 16 and AD is 10, BD is congruent to BE, find the measure of segment BC. We can illustrate our problem using this figure. Segment AB measures 16 and segment AD measures 10. We are asked to find the measure of segment BC. Segment DB is equal to 6 units, simply because the measure of segment AB minus the measure of segment AD is equal to the measure of segment DB, and that is 16 minus 10 equals 6. It is also stated that segment BD is congruent to segment BE. Therefore, if segment BD is equal to 6 units, we may conclude that segment BE is also 6 units. Using the two-secant theorem, let us form the equation. We will then have segment AB times segment BD is equal to segment BC times segment BE. By proper substitution of the given values, we will have 16 times 6 is equal to 6 times x. And that is equal to 6x equals 96. Dividing both sides by 6, we will have x is equal to 16. We therefore conclude that the measure of segment BC is equal to 16 units. Let us have our third problem. A tangent segment and a secant segment meet at the exterior of a circle at point B. If the length of the tangent segment is 9 and the chord segment included in the secant segment is 24, find the length of the part of the secant segment at the exterior of the circle. We can illustrate the problem using this figure. Point B is the point of intersection between tangent segment NB and secant segment GB. NB is equal to 9 units. GC is equal to 24 units. We are asked to find the measure or the length of segment BC. Using the secant tangent theorem, we may use the formula the square of NB is equal to segment BG times segment BC. By proper substitution, we will have 9 squared is equal to 24 plus x times x. The measure or the length of segment BG is equal to the measure of segment GC plus the measure of segment BC. That is why it is represented by 24 plus x. Simplifying the equation, we will have 81 is equal to 24x plus x squared. Distributive property is used on the right side of the equation. Let us now write the whole equation in standard form, and that is equal to x squared plus 24x minus 81 is equal to 0. Since this is now a trinomial, let us factor this one out. The factors of the trinomial are x plus 27 times x minus 3. The factors of negative 81, whose sum is positive 24, are 27 and negative 3. Equating both factors in terms of 0, we will have x plus 27 equals 0 and x minus 3 is equal to 0. Solving for the values of x, we will have x equals negative 27 and x is equal to positive 3. Since we are dealing with measurements or lengths, we are going to reject negative 27 since there is no such thing as negative 27 units. And we will accept positive 3. We therefore conclude that segment BC measures 3 units. Let us now check your knowledge. Try to solve the following problems independently. Kindly pause the video while you are doing this activity. Let us discuss the first problem. A tangent segment and a secant segment meets at the exterior of a circle at point B. If the length of the tangent segment is 8 and the chord segment included in the secant segment is 12, find the length of the part of the secant segment at the exterior of the circle. We can illustrate the problem using this figure. Point B is the point of intersection between the tangent segment and the secant segment. Segment NB measures 8 units, segment GC measures 12 units, and we are asked to find or identify the length of segment BC. Using the secant tangent theorem, we may form the formula the square of NB is equal to BG times BC. By proper substitution, we will then have h squared is equal to 12 plus x times x. Again, the measure of segment BG is composed of the measure of segment GC plus the measure of segment BC. That is why it is represented by 12 plus x. Simplifying the equation, we will have 64 equals 12x plus x squared. Rewriting the equation in standard form, we will have x squared plus 12x minus 64 is equal to 0. Factoring the trinomial, we will have x plus 16 times the quantity x minus 4 is equal to 0. The factors of negative 64, whose sum is positive 12, are 16 and negative 4. Equating both factors in terms of 0, that is equal to x plus 16 equals 0, and x minus 4 is equal to 0, which concludes that the values of x are negative 16 and positive 4. We are going to reject negative 16, simply because there is no such thing as negative 16 measurement, and we will accept positive 4. Therefore, the measure of segment BC is equal to 4 units. Let's have our second problem. In a circle, segment BF and DF are secant segments with external segments CF and EF respectively. If segment BC is 11 and CF is 5, EF is 3 less than CF, find the measure of segment DF. We may illustrate the problem using this figure. Segment BC measures 11 units, segment CF measures 5 units, segment EF measures 2 units, and we are going to identify the length of segment DF and represent it by x. Using the 2-second theorem, we may form the formula segment BF times segment CF is equal to segment DF times segment EF. Segment EF measures 2 units simply because segment EF is 3 less than the measure of segment CF, and 5 minus 3 is equal to 2. By proper substitution, we will arrive at 16 times 5 is equal to 2 times x. The measure of segment BF is equal to 16 simply because segment BF is composed of the measures of segment BC and segment CF, and that is equal to 11 plus 5. That is why BF is equal to 16. Simplifying the equation, we will arrive at 2x is equal to 90, dividing both sides by 2 to eliminate the numerical coefficient 2, that is equal to x is equal to 45. That means that the measure of segment DF is equal to 45 units. Thank you for watching Sir Ocnic's YouTube channel. If you think that this video is a big help, hit like, feel free to share, and do not forget to subscribe. Always have fun in learning math.